a question about infrared here. So give a harmful effect of infrared waves. If you think about what infrared actually is heat. So what we're looking for here is burns, okay? Now you can be more specific, but any kind of reference to burn or damaging skin cells is absolutely fine. But you must not refer to any kind of mutation or cancer, because it's not that kind of damage. It is a skin burn because of the heat. Then we're asked to give two similar properties of visible light and infrared. So these are both part of the electromagnetic spectrum. So we're looking for the common properties of those things. So you could say that they are both part of the spectrum. That would work fine. You make reference to the fact that both part of the electromagnetic spectrum. Or you could be a bit more specific and you could say, okay, well, they're both waves. What do waves do? Well, waves will transfer energy. So both of those will transfer energy. That works too. Or we could then be a bit more specific. What else do all electromagnetic waves have in common? Well, they're all transverse waves. So we could make reference to the fact that they're both transverse waves. They also travel at the speed of light. And the other thing that we could talk about here is the fact that actually, because they are both transverse waves, that means that they can both travel through a vacuum. So lots of opportunity here to talk about the similarities between these two types of transverse wave, and you just need to give two. Now we're being asked to give two differences between them. So if we think about the fact that they are both part of this spectrum and think about the properties within that spectrum, properties of waves we tend to think about are their wavelength and their frequency. So we're looking to compare here the difference between them. So the big thing here is the infrared will have a larger wavelength. Okay, so a larger wavelength. And of course, if we have a larger wavelength, what that means is the infrared also has a lower frequency. You could, of course, give the converse argument, so you could talk about it in terms of the visible light, but either of those will work. Now we're being asked to calculate the time taken for the waves to reach a car. We are given the distance that the lamp is from the car, and we are given the speed. So we need to go to our formula sheet here, and we need to use the equation for speed, which is that speed is equal to distance divided by time, and we then need to rearrange that to make time the subject. So time is equal to distance divided by speed. Then we plug our values in, so our distance is 1.5 meters and our speed is 3 times 10 to the 8. And when we work that out, that gives us a value of 5 times 10 to the minus 9 seconds. You can, of course, give your answer as 0.000000005, which is exactly the same. And here we're asked to explain the observation that white paint is going to take more time to harden than black paint. So when we're thinking about colours, we're thinking about the ability of colours to emit and absorb radiation. So in this case, we're looking at the fact that black is a better absorber. So black is a better absorber. And because it is a better absorber, that is going to mean that more energy is absorbed in a given time. So more energy is absorbed in the same amount of time. And again, you can give the reverse argument, so you can talk about the fact that the white is a worse absorber and therefore less energy is absorbed in the same amount of time. Either of those will work.